uh, to make it user friendly. Thank you.
Okay, thank you for the answer, Mr. Muhammad Salihul Hadi. That was a great presentation. Now we will move to the next presenters. I would like to invite Mr. Arya Kusumawardana. You there?
Yes, I'm here.
Okay, for Mr. Arya will present with the title Sensorless Control of PMSM using MPC EAF in low speed application for light electric vehicle. So now time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. My name is Yoga Prasetya and I'm from Department Electrical Engineering, University of Malang. In here, I want to explain to you about our research, and in the title is a sensorless control of PMSM using MPC EKF in low-speed application for light electric vehicle.
First, I want to explain to you about introduction of permanent magnet synchronous machine. Basically, PMSM commutation process requires sensor to determine the magnetic position. The position sensor for PMSM commutation has a crucial role. Sensor inaccuracies can cause error during the commutation process or speed control. In the next slide, we will discuss about problem statement. Permanent synchronous machine or PMSM have a problem sensorless application for low speed control on PMSM. And then permanent magnet synchronous machine have required how to design algorithm for sensorless PMSM at low speed and how to design algorithm for PMSM speed control. This is a figure 1. Figure 1 is about proposed scheme of sensorless PMSM control. For the next topic, we will discuss about a system model on PMSM model. To obtain the algorithm, we use this equation 1 and equation 2. Mechanical part of PMSM are shown in equation 3. For PMSM with multiple pair pole, electrical angular speed and mechanical angular speed have the following relationship in equation 4. Next discussion is about system model on 3-pass inverter. The sequential switching is shown in the table 1. Table 1 is about the switching state of 3-pass inverter. Based on the previous slide or the previous discussion, the following equation is obtained. In the next slide, we will discuss about purpose controller. On finite control set model predictive current controller. To obtain the algorithm, we use this equation or process. Considering that equation 1 and 2 are still in continuous time form, it is necessary to convert them in discrete form. The conversion can be approximated using forward Euler as follow equation 11 and equation 12. To obtain the optimal control signal, the cost function need to be minimized. The VCS MPCC is shown in algorithm 1, where is the output algorithm used to adjust the inverter switch. In the next topic, we will discuss about purpose controller on model predictive speed controller. The following is the form of the equation on model predictive speed controller. The following is a continuation of the equation from the previous process. From the description of the state prediction and output prediction can be represented in the form of a metric as follows equation 16. The following is a continuation of the process on model predictive speed controller. In the next, to obtain the algorithm, we use this question or process on a question 21, a question 22, and a question 23. The next explanation, we will discuss about purpose controller on extended Kalman filter. A standard Kalman filter is designed to estimate the PMSM state, including angular speed and position. When the system is described as follow a question 24. When iterating a standard Kalman filter requires linearization of the system, for this reason the following linearization is obtained a question 25 and 26. Because extended Kalman filter works with an interactive process, question 24 first need to be converted in discrete form on question 27. A standard Kalman filter consists of two main processes, prediction and correction process. The prediction process for the process is as follows: one prediction on a question 28 and correction in a question 29. In the next topic, we will discuss about simulation and result. A Simulink model of PMSM in MATLAB or Simulink is used to represent the model. The overall system parameters are shown in the table 2. To determine the effect of this parameter on estimation result, see figure 3. Figure 3 is about effect of Q parameter on omega m. To determine the effect of this parameter on estimation result, see figure 3. Figure 3 is about effect of Q parameter on omega m. The effect of changing this parameter on m is shown in figure 4. Figure 4 is about effect of R parameter on omega m. In the last topic is about conclusion. Conclusion number 1. The simulation results show that the algorithm for controlling the angular speed of PMSM, namely VGS, MPCC, and MPSC, produce good performance with the desired reference track capability indicator. Conclusion number 2. Estimation result using I-CoRE can also be used for sensorless PMSM control. Conclusion number 3. The combination of MPC I-CoRE can produce a good performance at low speed control, characteristic by the suitability of the estimate signal with the actual signal.
I think enough for my presentation and thank you very much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, thank you so much for Mr. Arya Kusumawardana team. They already present his paper. Now, maybe anyone want to ask the question? You can use chat feature or raise your hand and then unmute your microphone. So please. Is there any question? Okay, maybe I would like to ask question for Mr. Arya and team. Actually, I'm curious. May we can use this sensorless control for not only for vehicle, I mean for other things, something like that? Can you explain? Thank you.
Okay, thank you for your question. Maybe application for this MSM is can ex, and can ex, uh, can implemented on drone on electric car, and then on electric vehicle more, uh, maybe BMSM can implemented in electric vehicle. Modern electric vehicle is about motor electric vehicle or electrical motor. Maybe like this.
Okay, thank you very much for the for the answer. So actually, it can implement to the other things, right? Not only for vehicle things.
Yes.
Okay, thank you for the answer. So maybe there is another question for Mr. Arya and team. We still have 1 minute left before we move on to the other presenters. No? Okay, thank you very much for Mr. Yoga. They already present for Mr. Arya paper. Okay, thank you. Now
Yes.
we will move on to the other presenters. I would like to invite Mr. Sujito with the title Forecasting Energy Needs Based on Autogressive Integrated Moving Average. So for Mr. Sujito, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen, and honor to meet you in this beautiful day. Let me introduce myself. My name is Rizky Krismasya Putra, and for my supervisor research are Mr. Sujito, Mr. Muhammad Rodi Faiz, Mr. Abdullah Iskandar Shah, and Mr. Muhammad Zainul Fala. We are from Department of Electrical Engineering, State University of Malang, Indonesia. I would like to share about my research. The title is Forecasting Electric Energy Demand Based on ARIMA Autoregressive Integrated Moving Average in Banyuwangi City. In this presentation, I would like to explain about the four content of the paper that I have written. The four content are research background, research purpose, result analysis, and conclusion. The first I will explain to you about research background of this paper. The research background is in the current era with very advanced technology which most of the equipment uses electricity as its energy source. Research is needed for the growth of electrical energy need. Therefore, an accurate method is needed to predict the electrical load. So, in this study using the autoregressive integrated moving average ARIMA method, the ARIMA method is that the model completely ignores the independent variable in making forecasts. The advantage of this method is that it can accept all types of data models even though the process must be stationary. And then the second content is research purpose. On this paper, I have three purposes. Number one, to get the results of forecasting the electrical load using the autoregressive integrated moving average ARIMA method. Number two, to find out the best model for the autoregressive integrated moving average ARIMA method in forecasting this electrical load. Number three, to find out the MAPE value in this electrical load forecasting. And the three content I will explain result and analysis. The data analyzed in this study is data on the electrical load in the city of Banyuwangi for 60 period or 60 months starting from January 2015 to December 2019. The first way we have to see time series plot of data, and here is the graph. Based on the time series flow of data, it can be seen that the data is not constant with respect to B mean and variance at all time, so that the electrical load data is not stationary, so it needs to be differencing. And here is the graph after differencing. After differencing, it can be seen that the data trend to be constant towards the average and variance at all time. The second way is identification model from ARIMA. Model identification can be seen in the autocorrelation plot and partial autocorrelation plot. Based on the result of the analysis of the autocorrelation and partial autocorrelation different one plot, the autocorrelation plot is cut off after lag 1 and the partial autocorrelation plot is cut off after lag 2. So, the possible model are ARIMA 211, ARIMA 210, ARIMA 111, ARIMA 110, ARIMA 011. The next way is to test the significance parameter and verification H model. From the summary table of parameter estimation and model verification, the base model obtained is ARIMA 011 because the parameter significance test, residual normality test, and independent test are all met, and the MSE value show the smallest. The equation of the ARIMA model 011 is obtained as follows: xt amount min 0.1616 plus xt min 1 min 0.7612 alpha t min 1 plus alpha t. And the next step is forecasting. Forecasting results for the next 12 periods, and the results can be see table in beside. The last step of this research is to calculate the MAPE, and the MAPE result obtained are 5.116%. So, the conclusion is, from the research result, it can be concluded that in forecasting the electrical load using the ARIMA method, the best model is 011 for the forecasting result tend to be constant, and the MAPE value in this study is 5.116%. Thank you. See you on the next I-CoRE.
Thank you so much for your presentation, Mr. Rizky. Yeah. So for all the presenters, also for the participant, if you want to ask question, you can use chat feature or just raise your hand and then unmute your microphone. And here we have one question for Mr. Rizky. Can we use ARIMA approach for forecasting high volatility data? So please answer the question.
Okay, I will answer the question. ARIMA method is the best for forecasting. The best forecasting short term forecasting. So for high volatility, for can do, but better just for to forecasting short. Thank you.
Okay, maybe any feedback? Any feedback? All enough? Okay, maybe enough, the answer. So is there any question, another question? You can use chat feature and then raise your hand. Okay, it's enough. Thank you, Mr. Rizky, for your answer. Now, maybe we have another question. Please, you can raise your hand. If no, then we will move on to the next presenters. No question? Okay. Thank you, Mr. Rizky, for your answer and your presentation. Now we will move to the next presenter. I would like to invite Mrs. Diah Lestari, our team, to present. with the title Quadcopter Drone Design and Battery Power Consumption Analysis Against Flying Time and Distance. So for Mrs. Diah and Tim, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. In this section, I will present my study. The title of my study is Quadcopter Drone Design and Battery Power Consumption Analysis Against Flying Time and Distance. The first author is me, Sujito, and the other is Diah Lestari, Siti Sendari, Muhammad Ratibais, Mati Radikia Prasanta, Yohanes Sombing, and Yoga Pranata. We are from the Department Electrical Engineering, State University of Malang. Quadcopter is one of unmanned aerial vehicles that can fly vertically. Quadcopter developed currently focus a lot on autopilot feature and low drone to fly autonomously. In generally, a quadcopter consists of a flight control, ESC, and prowess motor as the main mover to performance role. Pitch, performance role, pitch, and yaw. In the research, we use the Big Hawk PX4 module that consists of the two layers. Normally, the flight stack layer, which function as flight control and estimation system, and the other is middleware layer, which function to support an automation system as well as to bridge internal or external communication with the hardware. This is the block diagram of the flight stack layer. Using the sensor, position, and altitude estimation, and position control, navigator, altitude, and the others component. In the system, the drone control from the ground station using the remote control and computer equipment in the head to off the mission planner application. The figure 2 represent of the block diagram of drone hardware configuration. And the other hardware is we're using the lithium polymer battery, Radiolinks SE100 GPS for position, and figure 5 description of the drone display design and dimension of the drone frame. When the drone is flying or operation, so there are several types of the power loss in drone on battery, such as back EMF loss or PM and power loss due to material use.
So we will play it again. So for operator, please play Mr. Suchito videos again.
Assalamualaikum warahmatullahi wabarakatuh. Gentlemen, in this section I will present my study from the Department Electrical Engineering. Role is of the two layers. Normally, the flight stack layer, which function as flight control and estimation system, and the other is middleware layer, which function to support an automation system as well as to bridge internal or external communication with the hardware. This is the block diagram of the flight stack layer. using the sensor, position, and altitude estimation, and position control, navigator, altitude, and the others component. In the system, the drone control from the ground station using the remote control and computer equipment in the head to off the mission planner application. The figure 2 represent of the block diagram of drone hardware configuration. The other hardware is we're using the lithium polymer battery, Radiolinks SE100 GPS for position, and figure 5 description of the drone display design and dimension of the drone frame. When the drone is flying or operation, so there are several types of the power loss in drone on battery, such as back EMF loss or PM and power loss due to material use such as iron loss and copper loss or PC. In the study, so we will calculate the power transmission loss like the EMF, power loss, and the other losses in the quadcopter. There are three results in the study. The first is we design the prototype quadcopter drone, and we trying to and the second is quadcopter drone flight test data, and the third is power consumption analysis on copter drones. Aku mau ngomong dulu mas ya. Fig 6 present the quadcopter drone prototype result from the design. The second is the second in the table 1 is a quadcopter power consumption flight mission 1. In the study we using the two mission. The mission 1 is the mission 1 have the movement lifting up, forward, backward, and landing. The mission 2 we have the movement lifting up, forward, left, then backward, right, and landing. To record the data flight, we must record all the data: time, rotation speed, distance movement, and power consumption. In the mission 1, we record data power consumption for quadcopter. The total power consumption in watts second. The total is 964.64 watts second. For the second mission, the total power consumption is 2169.2 watts second. This is the graphic, the battery consumption record of flight mission 1, and the figure 7 is the battery consumption record of flight mission 2. The data from the data experiment, we will calculate from the data. We will compare with the theoretical octarotary energy consumption estimation for each flight mission. For the flight mission 1, theoretical authority energy consumption we show in the table 3. So the total theoretical energy consumption in kilojoule, the total is 1047.6 kilojoule. So it means we have the ratio of the total energy consumption is 1.102%. So we compare formulation 1, the theoretical estimation and experiment. We have the error 8.6001%. For the second mission, the total theoretical energy consumption in kilojoule is 2362.5x kilojoule. So the ratio of total energy consumption is 2.486%. So comparison theoretical and experiment prediction flight mission 2 is we have the error 8.914807%. So the conclusion, the end of my present we will conclusion. Copter is designed using 4 brushless 920 kV motors, fixed hub, GPS, radio telemetering, receiver, ESP, buzzer, switch, and battery. Battery power consumption can be calculated from the calculation of the difference in the overall power of the component, with the battery capacity which is affected by displacement, time, and speed. The test was carried out with 2 different routes, namely the forward and back route and the rectangular route with a flight duration of 55 seconds and 2 minutes. From the test results, the present error with theoretical analysis and testing on flight mission 1 is 9.6% and percentage error from calculation and experiment flight mission 2 is 8.9%. Thank you.
Thank you so much for your presentation, Mr. Sujita. Now we are on question and answer session. We still have 2 minutes left before we continue to the next presenter. So is there anyone who want to ask question? Please, you can use chat feature or just raise your hand. Okay, please, Mr. Eric, you can ask question.
Okay, thank you, moderator. Hello, sir. I'm Eric from mechanical engineering student, sir. I want to ask you about what the excellence of this drone design if we compare it with common drone that usually we use. Thank you, sir.
Okay, in the research we use I think this is the commonly drone. It is the same of the commonly drone. Just we concern in how many power consumption in the drone when the drone is flying and having the maneuver and the other operation. So you will just calculate theoretical and experiment energy consumption. So I think this is the commonly drone. not I don't have the specific difference with the other zone. Okay.
Okay, how about the answer, Mr. Eric? Is enough?
Yes, enough.
Okay, thank you
Thank
for
you so much, sir.
Okay, welcome.
Okay, thank you for that question and also the answer from Mr. Suchita. Thank you for your presentation too. Now we will move on to the next presenters. I would like to invite Mr. Ari Priharta and Tim. There is anyone that represent him today?
Yes, I'm here.
Okay, thank you. Now please operator play the video.
Good morning. Today I will explain our research development of startup to gaining profit from research product on renewable energy. Let's start with introduction. The first author is Mr. Ari Harta from Department of Electrical Engineering, Universitas Negeri Malang. He also the member of Center of Advanced Material for Renewable Energy. The second author is me, Karim Firmansa, from Graduate School, Faculty of Engineering, Universitas Negeri Malang. The third author is Mr. Nandang Mufti from Department of Physics, Universitas Negeri Malang. He also member of Center of Advanced Material for Renewable Energy. The next author is Mr. Sujito from Department of Electrical Engineering, Universitas Negeri Malang. The last author is Mr. Guo Junhong from Department of Computer Science and Information Engineering, Southern Taiwan University of Science and Technology. He also the one of keynote speaker in this conference. The background of our research is universities in Indonesia have huge potential to generate income-generating products from research by lecturer and student. However, the potential is managed improperly, and the cooperative relation between the industry and universities are weak. Universitas Negeri Malang has taken it seriously on increasing intellectual works through research by lecturers and students under the command of LP2M. Research in creative technology and digital-based for TTG and education is very potential to be developed and commercialized with startups, such as Educate's 4.0 startup. This research focuses on launching a business incubator and realize the research into startup, training the lecturers confidence to market their products, adding future source of income generating UM, strengthening SPICA LP2M in commercialization of research product. This research consists of three phases. The first is startup establishment, the second is startup development and business development model. In startup establishment, we use the canvas business model to build a startup. This model consists of 9 points as shown in the block diagram. We mix product by doing UI and UX design, followed by design integration into an application and Educate's 4.0 system. After system is complete, we conduct the testing and evaluation. The following is a block diagram of the startup development phase. Research and development is based on customer feedback and innovation. The result of this research produce a product variants, evaluation and improvement, marketing improvement to increase startup capacity. The startup capacity is also increased through investment or infestation. Lecture research is carried out by students, accompanied and supervised by lecturers. The capacity of student abilities is increased through training and certification. This process involves alumni as a mentor. The startup has been built called Tidar Energy. This is startup array that has been created. The commissioners are Mr. Arif Harta and Mr. Muslim Paranda. Mr. Arif Harta also acts as a director where Mr. Adim Firmasa as a technician, as Mrs. Mary Nurlaili as a marketing officer. This is in the income earned in the last 6 months. Total income obtained from several products orders reached 60 million rupees from the capital of 65 million rupees or 90%. Some of the products sold are hybrid solar power plant and standalone solar power plant. We also conducted a customer satisfaction survey. The result was 85% of customers were satisfied with the service and the product provided, while 15% customers give a neutral response. Solar energy startups have been great potential when the trend of renewable energy currently reached 55%. The summary of this research is the start of the energy that was built to achieve the target, namely 50% turnover of the capital. The customer give positive response to the services and products, indicating great potential for startup to be developed in the future. Startup can provide additional experience for students and strengthen solution with alumni. Thanks for your attention.
Thank you very much for your presentation for Mr. Ari Priharta and team. Now we are on the question and answer session. So please, okay. Okay, please, Mas Aldi, if you want to ask question.
Test. Can you hear me?
Very clear.
Okay. Good afternoon, Mr. Adim Firmansyah. I want to ask you, can you hear me?
Yes, I'm here.
Okay. So, is that possible to make startup based on traditional culture related to renewable energy? So, what kind of startup do you develop in the field of renewable energy? Thank you.
Is it clear, the question, Mr. Adi?
Yes, clear.
Okay, please answer.
The startup develop is in renewable energy, especially in educate development and power system, solar power plant development. So we create a educate for learning media, and solar power plant for institution, especially for school and others.
Okay, Mas Aldi, how about the answer? May any feedback for Mr. Adi?
Can you repeat your explanation, please?
Okay. The startup develop is in renewable energy, especially in solar power plant and educates for learning media.
Now, Mr. Aldi.
The reason, any reason for the answer about what kind startup do you develop in the field renewable energy, like startup to control solar cell or any field engineering maybe?
Okay, please, Mr. Adi, you can give your answer.
This kind of the startup is in development learning media for educate, and the other product is solar power plant, hybrid solar power plant and standalone. So our startup is in development, especially kits and solar.
Okay, how, Mr. Aldi?
Oh, so that your startup still running in right now.
Yes.
Oh, okay. Thank you.
Can you repeat the question?
Your startup still running right now.
Yes.
Still running development.
Yes. In the last month, especially in September and October, we develop three solar power plant. The two power plant is in Malang and the one in Probolinggo city.
Okay, I think enough for your answer about my question. Thank you. Thanks a lot.
Yes.
Yeah, thank you very much for the question from Mr. Aldi and then the answer, also presentation from Mr. Adi. Now we will move on to the next presenters. I would like to invite Mr. Saparullah and team. Mr. Saparullah, you there?
Yes, I'm here.
Okay, thank you. Now we will move on to you with the title Study of the Configuration of a Piezoelectric Energy Harvester to Optimize the Power Extraction Order. Now, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. I would like to present my presentation titled Study of the Configuration of Piezoelectric Energy Harvester to Optimize the Power Extraction Order. The background of this research is there is a lot of electronic devices in our daily activity, daily life, and surround us, which need power to work, and we all commonly use power. We all commonly use battery as the main power source for our electronic devices, but it can produce chemical waste as battery waste, which absolutely dangerous for our environment. So in this day, we are using rechargeable battery as in our smartphone or in other devices. That's also this rechargeable battery. The power of this rechargeable battery is coming from power plants, which mostly in our country, power plant use coal as the main power source, and also produce chemical waste, dangerous for our environment. So in this research, we use piezoelectric transducer to power this rechargeable battery, or we can use it directly to the electronic devices with utilizing buck converter. So in this research, we can use this piezoelectric transducer directly using buck converter to power this some electronic devices, or we can use it for charging this rechargeable battery before using for this some electronic devices. We have an issue while using piezoelectric transducer, and this if we use a single chip of piezoelectric transducer, it only can produce power in microwatts order. So we have to do it in a multi-chip system, so we can obtain more power in a single output. In this research, we use 6 piezoelectric transducer, which is configured they configured in series and parallel configuration, and then we use diodes, silicon diode and Schottky diode as the for rectifier bridge, and we use capacitor to find out the power effective of the system. The first is we put this 6 piezoelectric transducer in 2x3 array, and then this 6 piezoelectric transducer is placed in between 2 acrylic planes, and then the system is pushed with 220 Newton force, and then the output of this configuration is rectified to obtain DC current of the output. In this research, we use 4 configurations. The first is the 6 piezoelectric transducer is configured in series configuration, and the single output of this configuration is rectified using one circuit of full bridge rectifier, and then the output of the rectifier is given capacitor. And the second circuit and the second full configuration is using we have here piezoelectric transducer is configured in parallel configuration, and the single output of this configuration is also configured using one circuit of full bridge rectifier, and the output of this rectifier is also given capacitor. And the third configuration is using is every single piezoelectric transducer is given one rectifier circuit, and then the output of each rectifier is configured in series configuration, and the single output of this configuration is also given capacitor. And the fourth configuration is every single piezoelectric transducer is given one circuit of full bridge rectifier, and the output of all of this single of full bridge rectifier is also given capacitor. The capacitor in our configurations then being measured, and we have here VC is the voltage of the capacitor, and this is the time. You can see this curve, time versus the voltage of the capacitor. These two curves, the first two curves is representing for single chip configuration, and the rest is representing representing the 6 piezoelectric transducer. We can see here for 6 series configuration using one rectifier silicon, and then this 6 series configuration using one rectifier Schottky, and you can see here it all using 6 piezoelectric transducers. This is for one rectifier, and this is using every single piezoelectric transducer for this curve, and this curve using you can see here using 6 rectifier. This is for silicon, this is for Schottky, and the last is parallel configuration using 6 rectifier silicon and using 6 rectifier Schottky. what we can obtain for this curve is the first, from this curve we have VC or voltage of the capacitor, and we have the value of the capacitor. We are using here 47 microfarad, and we can find out the VF, and we can find out the R from this formula. From this formula we can then found the P effective from this formula, P effective square over R. V effective is the voltage, effective voltage from the systems, and the R is the internal resistance from the system. Then if we put in the table, we can see here for single chip configuration we only have P effective in 0.67 milliwatts, and for such the rectifier we have 0.57 milliwatts, and the series and parallel configuration you can see here data the P effective. This is voltage, effective voltage. This is for the internal resistance of the system, of the configuration. This is the P effective, or the effective power of the systems. If we put it in this diagram, you can see here the effective power PF shows an increment up to 46% after being configured in multi-chip configuration. If we compare this one to this one, we can see that it is experience an increment up to 46%, and you can see this series configuration. This while using 6 FBR or rectifier silicon or Schottky, it shows good performance comparing to the only using one silicon or one Schottky rectifier. But in parallel configuration we have here the diode, the number of the rectifier is so insignificant difference, but still we have here for parallel which using 6 silicon rectifiers shows the best performance. That's all I can present to you. Thank you.
Thank you very much for your presentation, Mr. Saparullah and team. Now we are on the question and answer session. So if anyone want to ask question, please use chat feature, and also you can raise your hand and then unmute your microphone. Is there any question? Okay, maybe I would like to ask you a question, Mr. Saparullah.
Okay, go ahead.
Okay. Is there any side effect, I mean, for this process? If any, then please maybe you can explain to us. Thank you.
Yeah, absolutely. Everything have a side effect. We have in our research, this is a long-term research we will do, and this is the beginning of our research. So we just we only try to find in this beginning of this research, we would like to find out which one the best configuration we can do to make a multi-chip system of piezoelectric. And in the second step, maybe we would like to find out which one the material we can use as the best performance. And the side effect of this beginning of our research is that the material is this built from lead zirconated tannate, which quite dangerous for environment. So in the next step, we would like to use maybe some material friendly for our environment. Thank you.
Okay, thank you very much for your answer. It's clear for me. Maybe there is another question from the presenters or another participant. Please, you can use chat feature and also you can raise your hand. No? Okay. If there is no question, thank you so much for Mr. Saparullah for joining us today. Now we will move on to the next presenters. I will recall for Mrs. Siti Sundari and team. There is someone that want to represent her? No, still? Okay. And then now we will move on to another presenters. I would like to invite for Mrs. Dalila Matsaid or team with the title Development Cost Effective Solar Street Light at College Kemahiran Tinggi Mara Pasir Mas. So for Mrs. Dalila or Mrs. Nurhatini, time is yours.
Yeah, thank Assalamualaikum warahmatullahi wabarakatuh, and good morning to everyone. Before I proceed, let me introduce myself. My name is Nohatini binti Ibrahim from University Technology Malaysia. Today I would like to present my project is development of cost-effective solar LED street light at College Kemahiran Tinggi Mara Pasir Mas, Kelantan. This is outlines: first introduction, second problem statement, third objective, fourth scope, methodology, result and discussion, and lastly conclusions. For introductions, development of cost-effective solar LED street light, solar integrated utilized street lights, controller electronic timer for street light on-off switching operation using the solar energy for its power. They come with energy conservation option like dimming, as they are designed for energy efficiency. The buffer system is a function at 7 p.m. to 7 a.m. within 12 hours controlled by timer. The peak time when LED lamp is on during 7:30 p.m. until 9:30 p.m. when the motion sensor detects people or pedestrians near the street light. When no objects are across the street light, the intensity of LED lamp becomes 40%, whereby light dimmers. During my research, I have found 3 problem statements. First, the street lighting using conventional system using with halide bulb 150 watts. Second, the cost of maintenance is high for conventional street light. Third, the build electricity expensive by using conventional street light at KKTM Pasir Mas. The aim of this project is, first, to model and simulate the LED streetlight system using solar panel. Second, to design and develop the solar street lighting LED at KKTM Pasir Mas. Third, to perform economic analysis of the proposed system. There are several scopes in this project. Okay, first, solar panel, use 250 watts polycrystalline. Second, use solar controller battery, which is 12 volt 30 amperes. third mini LED headlight, which is used 50 watts and 40 watts. And fourth, rechargeable LED battery, use 12 volt 200 ampere hour. And lastly, motion sensor, which is a direct current 12 volt and 180 degree. Okay, this is the schematic diagram for the purpose system. We start with the solar PV. So we'll connect to the circuit breaker and then go to the charger controller. Also, battery lead acid will connect to the circuit breaker and to the charger controller. The timer will connect to the relay and relay connect to the LED and the motion sensor. Okay, so this is the schematic diagram for the purpose system, which is for the LED strip lighting. So this is the design for the purpose system using SimuliMATLAB. Okay, this is the result. We have run from the SimuliMATLAB. So for the battery lead acid rechargeable, as you can see here, the battery is uncharging from the PV array, means no irradiations. Once PV array detect the irradiations, so the battery is charging. Okay, so it shows here. Okay, so here irradiation PV array was detected irradiations, so the energy will store. So when energy is stored, the voltage also increasing. So when the PV array not detect the irradiations, so the current in negative region means the battery is uncharging. Okay, so this is the process the battery lead acid to charge from the PV array. And then second, for the load of power consumption of the LED. Okay, so for the first graph is a brightness lamp is 40%, means it's used 40 watts. Okay, so at this time there is no object or pedestrian across the street lights. Okay, the brightness of the lamp is 40%. Also the same with the 100 watts. Okay, at the same time, okay, the brightness of the lamp is 40%. For the third graph, so we can see here, okay, the load, the power of consumption of the LED at certain time. Okay, so as you can see here, the result is the peak time of 8 p.m. to 8 p.m. Okay, the more energy is used compared to the in the morning is at 12 a.m. to 5 a.m. Okay, so we can conclude here we can reduce the uses of the power of consumption of electricity. Okay, so this is the result we obtained from the SimuliMATLAB. This table shows the cost estimate of installation for all KKTM. Okay, this is the graph to show the cost estimate of installation for all KKTM between SL conventional system and also the system purpose. So overall, we can saving the cost is about 483,636 ringgit. This table shows the cost estimate of installation for all I-CoRE. Okay, the graph shows the cost estimate for all installation for I-CoRE between SL conventionals and system purpose. Okay, so the total cost saving is about 405,552 ringgit. This is the result of the solar LED strip lighting was successfully developed in KKTM Pasir Mas. Discussions. For the result, we found that the total bill electricity is about 1,060 ringgit 35 cents per monthly and 12,722 ringgit 76 cents yearly for the proper system in KKTM Pasemas. Saving costs for installation for all KKTM and I-CoRE is about 889,188 ringgit. For the payback, this period is about 1.35 years. Therefore, using this proper system, which is solar LED street lighting, we can reduce the demand for load from TNB as well as save electricity bills. We achieve to get the cost effective from the system. LED and the motion sensor can reduce the power usage of solar, which can cause the street light to function for one night is about 12 hours. By using sensor as well, we can extend the life of the lamp. Conclusions. Development of solar street light LED at KKTM Pasemas was successful and the cost if they are achieved where the cost of electrification become enormously highly, one can always use an off-grid PV system. Thank you for listening. See you on the next I-CoRE.
Thank you very much for your presentation, Mrs. Nurhatini. Now
You're
we are on
welcome.
question and answer session. Please, for all the presenters or participant, if you want to ask a question directly to Mrs. Nurhatini, you can use chat feature or just raise your hand and then unmute your microphone. So please, is there any question? Okay, maybe I would like to ask you a question first
Yeah,
before
thank you.
well we are waiting. Okay,
Okay.
actually I'm curious. This thing already implemented in my Civ Public or still developed?
Okay, this system also successfully developed in my college. Okay, but I just developed for one pole. So it was successfully as you see in my slide before this. I showed the result from the hardware at the in sunny and in the night. So it was successfully developed using for only for one pole. So in coming, I recommended to my boss to implement the more that system to come more give cost effect users of the bill electricity become less than as usual. Okay.
Okay, thank you very much for your answer because there is we will I hope that you will back again to this breakout room in 5 seconds because there Okay, for all presenters, also participants, we are really sorry for the technical problem. Yeah, it's already twice happened, but it's okay. So we will continue with Mrs. Nurhatini. Is there any other question? No, maybe I would like to continue my questions. Sorry.
Okay.
Okay. Actually, I want to know, you already explained about the advantage and etc., but I want to know more about it. So, what the advantage and excellences for your things that you already developed,
Uh,
if we implement it on your areas or on your
College.
district or something like that. Okay,
Okay,
thank you.
so my advantage is my the cost of the development is very cheaper rather than the provided in TNB, our in country. Okay, so the comparison between the cost of development. So uh, I am very sure if that implement in more in my college, so that can reduce the bill electricity, and then the cost of maintenance also is more than like normally is a conventional, we have to maintenance 2 years, but if you implement this my purpose system, so it's more than 20 years, we uh, can do another maintenance. So that's I very ensure and I very proud the system very good and function very well.
Okay, thank you very much for your answer, Mrs. Nurhatini. It's very clear for me, and good luck for the next development of
Yeah,
these things.
thank
Okay,
you.
there is any other question for Mrs. Nurhatini before we move on to the others presenters? So please, is there any other question? No? Okay. Thank you, Mrs. Nurhatini, for joining us today.
Yeah,
Now we
welcome.
will move on to the next presenters. But before, let me remind you to fill in the attendance form and make sure that all your fill in is being recorded by our system. Okay. Now I would like to invite Mr. Hadi Suyono or team to present with the title Islanding Operations Strategy to Improve the Stability of Hybrid Distributed Generation Based Power System. For Mr. Hadi Suyono or team, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Saman Abdurrahim. I'm from Brawijaya University. And in this presentation, I would like to discuss an operation strategy to improve the stability of hybrid distributed generation based on power system. Introduction: distributed generation systems are generally based on new and renewable energy sources, and the injection of distributed generation can be utilized to optimize the reliability of electric power system. System stability. System stability of electric power system can be defined as the ability of electric power system to maintain its synchronous state during and after disturbance. The stability of electric power system divided into three categories: the frequencies, voltage, and the rotor energy stabilities. Defense scheme. Defense scheme is a protection scheme that is used to protect the system when abnormal conditions occur in system operation. Defense scheme is required to avoid the system collapse and to restore the system stability in order not to produce any damage to system equipment. The islanding operation. Islanding operation in the reference scheme implemented by ultimately separating the generating unit from the existing power system under disturbance and letting it carry only a limited load based on its capacity. Islanding transition scheme requires fast and response from local energy resource to establish secure islanding. A non-critical load must be disconnected during landing operation to limit associated loads until grid supply is resumed. Next slide, the method. As we can see in the research flow diagram, the first step is data collection and then system modeling on system single line diagram using a tab software. The object of the study in this paper is the Pujon feeder, which is supplied from Sengkaling substation in Marangan Sea, Indonesia. Based on preference research, the Pujon feeder can be injected of new and new renewable energy has distributed generators, especially solar power plant of 1.3 MVA and micro hydro power plant of 15 GVA. Then that full simulation and analysis, and then transition stability simulation analysis. The stability study to do includes the frequency, voltage, and rotor angle stability. And then the next step is transition stability simulation and analysis of permanent circuit fault and using calculus precision base with islanding operation mode. And I will look the response is stable or not. If yes, we conclusion suggestion, and now we make a system recommendation. The frequency standard drop based on IEEE. The upper limit is 50.42 Hz and the lower limit is 49.58 Hz. The voltage standard using PLN standard, the upper limit is 5% and the lower limit is minus 10%. Result of load flow analysis. As you can see the table, there are four conditions. The first condition is existing and the fourth condition is the injection of solar and micro hydro. The injection of distributed generators can decrease the losses, as you can see in the first and the fourth. And in the figure, the injection of the distributed generators can improve the value of the voltage. And the first condition is a blue, and the fourth condition is a red. Result of transition stability analysis. As we can see in this singularity diagram, this is a 6 section. Each section is separated by section and reserves. The solar power plant is supply section 6 and the microhydro is supply section 4. The next of the result of transient stability. The transient stability simulated with circuit fault on bus 1 at the time of 3 seconds and then at the time of 3.15 seconds islanding mechanism by opening the entire 16 resistors and then analyze with the frequency and level voltage response of the bus 1, bus 57 and the bus 117 and the rotor angle of micro hydro power plant. As you can see in the table, the section and the generators and the total capacity and the total generation are shown. The next result of transient stability analysis. The first figure, as you can see, the bus frequency, bus 1 is beginner rise, cause of permanent circuit fault, and the frequency of bus 117 is remains stable at 100%. And then the bus of 57 is begin rise to the 102.86% and then stable at the 102.58%. Where the frequency response of the airline mechanism does not in accordance with the standard used. In the bus voltage, as we can see, the bus 1 it's began drop to 0%, and then the bus 117 is decreased to 10% and begin to rise to 112% and stable in there. And then bus 57 and drops to 8% and then continue decrease until 0%. The voltage response is not accordance with the standard used in PLN standard. The relative power angle, and the micro development so that the highest point is at the 33.36 degree and then decrease to the 0 degree because when the section is open condition, the micro power plant which initially operates as voltage control changes to swing mode for each section. The response of the frequency voltage is not stable and require recommendation. The result of tension stability with the recommendation based on previous simulation. In the recommendation, added two synchronization is 6 and 4, 1 and 2, and then divided load 32 of 100 kVA into load 32A 9 kVA and load 32B of 121 kVA, and added one 600 in 6 and 6 right here. As of tension stability recommendation, the stable stimulation is same as previous, except not applying the 606, and the total load and total duration, as we can see in the table. The result of tension stability with recommendation, the bus frequency. After being given a recommendation, the system becomes more stable, and the frequencies of bus 57A and 117 can return to a level condition, and the frequency response does in accordance with the standard used. The bus voltage, the bus of 57A and 117 can return to a level condition, and the voltage response does in accordance with the parent standard. And the relative power angle is same as previous. The average value is 23.36 degrees, and then decrease at 0%. Because of the microhydro power plant, which initially operates at voltage control, just to swing modes. The response frequency voltage is stable. Conclusion: the first was the flow simulation. The addition of the register as a system can improve the voltage level and can also reduce power losses. As the addition of the generators can stabilize the response of frequency, voltage, and rotor angle in the system. The tension stability simulation result, the system change to the ending mechanism does not affect the frequency response, but cause of voltage in solar power plant, and causes over frequency and under voltage in micro hydro power plant. Tension stability simulation of the LND mechanism with the addition of the distributed generators and synchronizers. The solar power plant can recover section from other voltage to normal condition, and can also improve the tension stability response of micro hydro power plant. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, thank you very much for your presentation, Mr. Hadi Suyono and team. Is there anyone want to ask question? So you can use chat feature or just raise your hand and then unmute your microphone. So please, for all presenters, also all participants that joining in this parallel session, you can ask the question for our last presenters this afternoon. Okay, Mr. Hadi Suyono, maybe I would like to ask question for you.
Yes, ma'am.
Okay. Okay, Mr. Muhammad Salman. Okay, I would like to ask question, what the most factor if you want to implement this strategy? Thank you. You hear me?
Yes, I'm here. Can you explain the factor?
Yeah, so I'm asking about what the main factor or the most factor or challenge. It depends on your explanation. If you want to implement your strategy, because islanding operation strategy you use for this or your research, right? So I want to know what the most and then what the main factor if you want to implement this thing, this strategy, of course.
Oh, okay. The main strategy to operating islanding is the transition scheme. It's required a fast response from the CB to cut the fault. It's required fast response because as fast as the CB cut the disturbance,
and the islanding operation is occur. The generator or the local energy is established to secure the landing system or the system which is can be supplied. Okay.
Okay, thank you for your answer, Mr.
Okay,
Muhammad
you're
Salman.
welcome.
Thank you too for your presentation. Is there any other question maybe from presenters and also participant in this parallelization? We still have 1 minute left before we end this parallelization. And also I would like to recall again, before, is there any question for Mr. Hadi Suyano and Tim or Mr. Muhammad Salman? No, no question? Okay, if there's no question, I would like to recall again for the last presenters that not present yet. For Mrs. Siti Sundari and Tim, there is anyone that want to represent her paper? Still no? Okay. If there is no who want to represent for Mrs. Siti Sundari, then we are on the end of this parallelization. Thank you very much for our last presenters, Mr. Hadi or Mr. Muhammad Salman and team, for your presentation. Now we are on the end of this parallelization. I would like to remind all the participants and also...
Duduk Mbak, lihat. Enak banget duduk. Mundur.
Okay, sorry. Again, now I would like to remind all of the presenters, also participants, to fill in the attendance form and make sure that it's being recorded by our system. And also for tomorrow agenda, I would like to remind all of the presenters, also participants, to rejoin again, because we still have 3 keynote speaker, the great keynote speaker that will explain their knowledge for us. And also it's mandatory to get the certificate. So please make sure tomorrow you, all the participants and presenters, rejoin again for our conference, International Conference on Renewable Energy 2021. Now, before we end, please take a picture together. So operator, maybe you're ready to take a picture of us. So please turn on your camera. So for all the presenters, also participants, please turn on your camera. Yeah, I will wait for all of you to turn on your camera. Okay. Yeah, we are still waiting for the other participant and presenters to turn on your camera to take a picture together. Also, this is as a proof for your attendance in this parallelization. And also, please fill in the attendance form too, today and also tomorrow. Okay, operator, are you ready to take a picture? So I would like to count 1, 2, 3. Once more. 1, 2, 3. No, maybe you can smile or use your freestyle is okay. Once more. Once more. Yeah. Once more. 1, 2, 3. Okay, thank you very much for joining this conference, especially on the first day. Tomorrow we will meet again on the second day on our international conference on renewable energy 2021. So thank you for this great meeting today and discuss this afternoon. I hope that all of us in a good condition and also stay healthy. Thank you very much. I'm sorry if I have a mistake. See you again tomorrow. Wassalamualaikum warahmatullahi wabarakatuh. All the participants can leave this room. No need to go to the main room. We will meet again tomorrow. Okay? See you.
2009. It has strengthened its vision as a learning organization and as